All right, so we have had several patterns over the last several days. And some of the patterns have been easier to figure out, and some of them have been more difficult, right? What makes the easy ones easy? How do you figure out the easy ones? What tends to be their pattern? What are the easy patterns to figure out? It's not so easy when there's an exponent or something. What makes something easy to figure out?
When the numbers are put on like a straight line.
And in those patterns, we typically are adding or subtracting the same number each time, right? So that's where we get this type of sequences. Now, tiny little English lesson for you. What is this word right here?
Arithmetic.
A lot of people want to say arithmetic. When it's a noun, it's arithmetic, but in this case, it's an adjective. It's describing the sequence, so it's pronounced arithmetic. Okay? Just so that you don't think I'm purposely pronouncing it wrong. I'm purposely pronouncing it the way it's supposed to be pronounced. So this is arithmetic sequences. In arithmetic sequence, you add or subtract the same number every time. Okay? You add or subtract the same number every time. Okay? So, I'm going to turn my paper over for a minute. So if you were given a sequence like this, we would write it in a table, right? And we would go, the first term is 4, the second term is 8, the third term is 12, the fourth term is 16, right? And we would say, okay, it looks like they are adding 4 each time. And that's our constant thing going on right there. Yeah? We all good in the same place right now? Give me thumbs up if we are. Awesome. What if I had a pattern like this? When I set up that one, what is the common change here? It's subtracting 2 each time, isn't it? 4, 2, and so on and so forth. You can see it's a -2, -2, -2. Now, I can identify that without having to go to the XY table, can't I? I can identify that kind of by just noting it here, right? Now, something that's interesting, this particular number that ends up being common is called the common difference. Whoops, sorry. Common difference. And we use the letter D to represent it. So in this particular sequence, we would say D equals 4. And in this one, we would say D equals -2. Does that make sense? Does anyone remember, now last class I had up a table and a graph and an equation all at the same time. Do you remember that? And the table, it actually had a +2 on it. And I said, where's the +2 on the graph? And you guys said, oh, it's how far it's going up to get to the next point. Do you remember that? No? Yes? Okay. And then it was also in an equation. Do you remember where it was in the equation? Anybody remember that? That magic word? It was known as the slope. So our D value is also our slope. So when we're talking about an equation kind of like this, D is our slope. Okay? So let me turn this over. Now, you hopefully noticed that on the home page there are 2 homework assignments tonight. Not just 1, 2, but they are due Sunday by midnight, not tomorrow. But the first homework assignment is called Arithmetic Sequences Worksheet, I think is what it's called. This is what the first set of problems is like. This is what the second set of problems is like. And this is what the third set of problems is like. Okay? So this right here, what I'm going to show you now, is how you're going to be able to do all those problems. Now, I need to get a little formal with you. Okay? So these arithmetic sequences are the sequences where you add or subtract the same number every time. This is going to be a very important sticky note. You ready? Because we learned 2 types of formulas, didn't we? We learned a recursive, right? We also learned an explicit. And for our recursive one, we said like now equals the previous plus something, or now equals the previous times something. Well, we actually want to put it in formal math notation now. So on a recursive formula, you would say f of n is equal to f of n minus 1 plus your d value. What's my d value again? It's that common difference. Okay? So this is your now. This represents now. And this represents previous. Okay? In addition to that, a recursive rule, you always have to include what the first term is. A recursive rule cannot not give you the first term. And I'll show you why when we do number 1 here. Okay? Now, I'm going to hold off on the explicit one because we don't need it till number 2. So let's just focus on the recursive right now. Do you see how this is in this exact form? Now is equal to the previous plus 100. What does that tell me my d value is? If it's asking me to find the common difference, what's my d value? Anybody? 100. Because that's the number that's being added. Now, what if this was a minus 100? What would that make my d value? Negative 100, exactly. Okay? Now, so, given the recursive formula for an arithmetic, find the common difference, done. And the first 5 terms. Now, I may be a nerd, and I'm okay with that. But I like putting 5 lines so that I know exactly how many terms I have to find. Now, pretend they didn't give me the first term yet. Okay? And I was trying to find the first term. If this is now equals previous plus 100, how am I supposed to find this if there is no previous? I can't, can I? That's why they have to give you a term to start off with. So I'm really only needing to figure out 4 terms because they're already giving me one. Now I have somewhere to start with. I can say, okay, if I want to find this one, now is equal to the previous plus 100. So what is negative 38 plus 100? 62. And then that common difference says I just keep adding it. So 62 plus 100, 162. And then what? 262 and 362. Because again, that common difference means you just add 100, add 100, add 100, add 100. So there is the first 5 terms of that sequence. So? What's nice is if you can identify that a sequence is arithmetic, You never again have to sit there and stare to figure out what the formula is, because this is your shortcut. You know this is what the formula is. But keep in mind, this f of 1 is part of the formula. Because when I covered that up, we couldn't write any terms of the formula without a starting point. Okay? Questions about the recursive there? Okay. What I'm trying to do is I'm trying to take what we've been doing and put the actual math notation to it. Okay? So now let's look at number 2. Okay? Number 2 says, given the explicit formula. You see that? All right, you ready for the explicit formula? Explicit formula is f of n is equal to f of 1. That is referring to the first term. So you take the first term plus d parentheses n minus 1. So that one's a little trickier. You take the first term, add d, and multiply it by n equals 1. Now I'm going to show you how to go from there, or how to get that. But do you notice that this doesn't look like that? This doesn't have parentheses in it, right? This one's a lot simpler. Yeah? I'll show you how you get from here to here on the next problem, okay? But for right now, I need to find the common difference. So I'm actually going to flip to the back for a minute. Remember how I said the common difference is the slope? In other words, it's the coefficient of x. Well, I don't have x, I have n. But what's the coefficient? Isn't that 20? I think my d value is 20, but I'm going to show you how to find it a different way. You ready? I have to find 5 terms. 1, 2, 3, 4, 5. And to find the first term, I'm looking for f of 1. How do I find f of 1? I take this equation, negative 49 plus 20, and I'm going to plug in 1 for n. So that's negative 49 plus 20 times 1 is 20. What is negative 49 plus 20? Negative 29. What did I just find? The first term is negative 29. Now I want to find the second term. Holy crap, Mrs. Franken, are you going to make me do this for every single one of those blank 5 times? No, we'll get a shortcut as soon as we do this one, okay? So, negative 49 plus 20 times 2. Well, negative 49 plus 40 is what? Negative 9. So my second term is negative 9. And remember, they're telling me it's arithmetic, so I know that they are adding or subtracting the same number every time, which means that whatever they added here is also going to be what they add here and here and here. So what did they add to get from negative 29 to negative 9? 20. So I was right. D does equal 20. And how do I find the remaining values? I just keep adding 20. So negative 9 plus 20 is 11, plus 20, plus 20 again. There's the remaining terms. So I don't have to do this process for all 5 terms, because if I can get 2 and identify that d value, it lets me take a shortcut for the rest of them. Okay? So again, the first set of problems on your homework is this recursive one, like number 1. The second set is like number 2 here, where it's explicit. Okay? So? Good answer. All right. Find the common difference, the explicit formula, that's f of n equals, and the 52nd term, that's f of 52. So again, if I have my sticky note here, this explicit formula is going to come in handy here. Okay, so keep it nearby. So, common difference should be fairly easy to find, right? I just have to figure out, well, first off, I know they're adding something. How do I know they're adding? Well, they're going from a negative number to a positive number, so that has to be addition, right? What are they adding? Well, it's hard to see there, but here I think I can see they're adding 30. So my common difference is 30. So far, so good? Okay. Now let's talk about our f of n thing. This is where I'm going to show you how to go from this formula to the simplified form that we saw in number 2. So I start off with f of n equals. It says f of 1. That's the first term. What's the first term in this sequence? Negative 22. That's the first thing I write down. Then I write down plus d, and I found out that d was what? 30, parentheses, n minus 1. So far, so good? Now again, this still does not look like the equation I was given up in number 2. Number 2 only had 2 terms in it. This has parentheses and some craziness. Well, I have to do a little bit of work here because I can use my distributive property to do some simplifying. That gives me f of n equals negative 22. What do I have here? 30 times n is 30n, and 30 times negative 1 is negative 30. And you are always going to have one set of like terms right there. So add those together. Negative 22 plus negative 30. You can use your calculator if you want to. Just make sure you include the negative sign there. Whoop. Is negative 52. And then the plus 30n. Now I have something that is as simple as what I saw in number 2. So my explicit formula is negative 52 plus 30n. Okay? That's probably the hardest type of problem you'll see. Okay? I'm not quite done yet, but the last step is easy. How do I find f of 52? Well, I take the formula I just got, and to find the 52nd term, I plug in 52 right here for n. So negative 52 plus 30 times 52. So let's see. Okay, hang on just a minute. 30 times 52, 1560. Yeah? And I think I heard you say 1,508. And you can just put it straight from here into your calculator. So 1,508. And those 3 pieces are what the instructions were asking for. Okay. All right. I want you to take a minute and start off number 4. See what you can do without me. And then I'll jump in a couple minutes to hopefully get you unstuck if you're stuck somewhere. Okay. Again, keep this formula nearby because you're going to need it in this step right here. Okay. So number 4 is done exactly like number 3. See what you can do with number 4. Okay. you have any questions for me, please send them to me. You can send them to me privately in the chat box if you don't want to share with everyone. But I should see everyone working on this. Right now I have 12 people without their camera on. If you could either turn your camera on or send me a message saying why your camera doesn't work or whatever, okay? That would be helpful. What is my D value here? What are they subtracting? So my D value is negative 100. Okay, so I'm going to use my formula, f of n equals f of 1, that's the first term. What's the first term here? Negative 28. Now this says plus D, but my D value is negative. So I'm going to either write plus negative 100, or what can I write instead of plus a negative?
Subtract.
I can just write minus 100 and then n minus 1 in parentheses. At this point, what do? Distribute, right? So f of n equals negative 28, and then negative 100 times n is negative 100n, and negative 100 times negative 1 is positive 100. Yes? And I said you're always going to have one set of like terms right there. So go ahead and add those. Negative 28 plus 100 happens to equal 72. And then you have your minus 100n. Okay? So my formula is 72 minus 100n. Alright, I'm almost done. To find f of 52, or the 52nd term, I come back here, f of 52 is equal to 72 minus 100 times 52. So that is 72 minus 5200, right? What was that? Am I doing it wrong?
No.
Okay. I get negative 5128. Okay. So again, one of your two assignments that's assigned today, not due till Sunday night at midnight, has sets of problems like the 4 that I just showed you here. Okay? There's no video to go along with it. There's only this right here. Now, I have been making a video. I've been recording this, so I'm going to go ahead and stop that video since we're finished with